Hello guys, welcome back to the channel. So for those of us who may be new to this channel, my name is Frimpong Emmanuel. I completed KNUST in 2023 and currently I'm doing my PhD in mathematics at the University of Nevada, Reno. So don't worry, you're in the right hands. So let's start with the differentiation from the first principle. It says that let f be a real valued function. Now, a real value function means that the output of that function is always a real number. So that's what we mean by a real value function on an open interval. Then the rate of change or the derivative of f of x is giving us the limits as h goes to 0 of f of x plus h minus f of x divided by h. So this is just a simple expression. So that's how we are going to find the rate of change of f or dy dx of f. So now let's start with our first example. So from the first principle, this is the formula that we are going to use to solve this given question. So now first of all, let's find f of x plus h. So now f of x is defined as x squared. Now our goal is to find f of x plus h. So this means that if we see x in the f of x function, x is now equal to s plus h. So now we have the f of x function giving us x squared, right? But now x is now what? X plus h. So we are going to have s plus h all squared. So this will be your f of x plus h. So now let's expand. So this means that s plus h multiplying itself twice, and by binomial expansion x will multiply this guy and h will also multiply the whole of this guy. So we are going to have f of x plus h is equal to x multiplying x plus h multiplying s plus h. So we are going to have x squared plus sh plus sh plus h squared. So now let's group like terms and add. So we are going to have x squared plus 2sh plus h squared. So this is your f of x plus h. So now we now know f of x plus h, and f of x was giving us x squared. So we now have all that we need. So now let's just substitute it into the first principle formula. So here we know f of x plus h to be this guy, and f of x is giving us x squared. So we are going to have limits as h goes to 0. Now what's f of x plus h? That's x squared plus 2sh plus h squared. Then minus f of x. So minus what's f of x? That's x squared divided by h. So now let's simplify further. So we are going to have limits as h goes to 0, x squared plus 2sh plus h squared minus x squared divided by h. So x squared and x squared will cancel out. So these two guys will cancel out. So our expression will be limits as h goes to 0 of 2sh plus h squared divided by h. So now we have to find the limit. So now if we want to find the limit, the expression should be in its least form, right? So here we can factorize h out. Factorizing h out gives so here h will cancel h. So we are going to have limits as h goes to 0 of 2s plus h, which will be given as 2s plus 0, and that's 2x. Alright, so now let's try our second example on the first principle. So here we have f of x to be equal to 1 over x. So from the first principle, we need f of x plus h. So now let's find f of x plus h. So here, wherever we see x in the f of x function, we are going to substitute in x plus h. So we are going to have 1 divided by, here is x, but now x is what? X plus h. So here is going to be x plus h. So now let's substitute this into the first principle formula. So here we are going to have limits as h goes to 0. F of x plus h is giving us 1 over x plus h minus f of x is giving us 1 over x, then divided by h. Let's take the numerator out and simplify it further. So we have 1 on x plus h minus 1 over x. So let's find the LCM. The LCM will be giving us s plus h multiplying x. So we are going to have x minus x plus h, that's x minus h, x squared plus sh. So this x will cancel out. So our answer will be giving us minus h on x squared plus sh. So that's the numerator is giving us minus h on x squared plus h. So we are going to have minus h divided by x squared plus sh, then all divided by h, and this is equal to limit as h goes to 0 minus h on x squared plus sh multiplying 1 over h. It's multiplying because when we have, let's say, a on b divided by c, we are going to have a on b multiplying, then we invert the c, so that will be 1 over c. So we just apply the same idea here. So here this h will cancel out this h, so we are going to have limits as h goes to 0 of minus 1 on x squared plus sh. So now let's take the limits as h goes to 0. So now taking the limits as h goes to 0, this part will go to 0. Alright, so we are going to have minus 1 over x squared, implying that dy dx is giving us minus 1 on x squared. So let's solve our third example on the method of the first principle. So here we are given f of x to be equal to 3 on x squared plus 1. So by the first principle, we need f of x plus h. So f of x plus h will be giving us, here wherever you see x, you are going to put in x plus h. So we are going to have 3 divided by, now here is x squared, but now x is what? X plus h. So here is going to be s plus h all squared, then plus 1. So we can simplify this to get 3 divided by x squared plus 2sh plus h squared plus 1. So now let's substitute this into the first principle formula. And we now know our expression for f of x plus h. So we are going to have limits as h goes to 0, 3 divided by x squared plus 2sh plus h squared plus 1 minus, now what's f of x? That's 3 divided by x squared plus 1. then all divided by h. So here let's take the numerator out and simplify it further. That's taking this guy out and simplify it. So we have 3 divided by x squared plus 2sh plus h squared plus 1 minus 3 on x squared plus 1. So let's find the LCM. So the LCM will be giving us the products of the denominators. So now let's simplify further. So now let's add these two functions by finding the LCM and simplifying. So we are going to have, so now this will be simplified to 3x squared plus 3 minus 3x squared minus 6sh minus 3h squared minus 3 all divided by. So now here this will cancel out and 3 will also cancel out, so it will be left with minus 6sh minus 3h squared divided by the denominator. So this is the expression for the numerator. So now let's substitute this back into the first principle formula. So we are going to have limit as h goes to 0 of the numerator, and that's what we just solved to get minus 6x h minus 3h squared all divided by h. So we are going to have minus 6sh minus 3h squared divided by h multiplying x squared plus 1 x squared plus 2xh plus h squared plus 1. So here we can factorize h out from the numerator. So factorizing h out gives, so here h will cancel h, so we are going to be left with the limit as h goes to 0 minus 6x minus 3h divided by x squared plus 1 x squared plus 2sh plus h squared plus 1. So now let's take the limit as h goes to 0. So as h goes to 0, this part will go to 0, this guy will go to 0, and this will also go to 0. So we are going to have minus 6x divided by x squared plus 1, then x squared plus 1 again. So which will be simplified to minus 6x divided by x squared plus 1 all squared. So that's dy dx is giving us minus 6x on x squared plus 1 all squared. Alright, so that's the end of today's video. Please make sure to subscribe and leave a comment. See you next time.